Welcome back to Old School Math. Today we're going to take a look at finding the greatest common factor. Now, finding a greatest common factor is something that you've probably done with numbers before in a middle school or elementary school math class, but we're going to take a look at how to do this with variables. And the greatest common factor is just the largest possible number or variables that divide into each term in our polynomial. They have to go into each term for it to actually be a greatest common factor. Now, the reason that we talk about the greatest common factor is because it's important to factor this out before we go into other factoring processes in our polynomials. The way I recommend finding the greatest common factor is to write polynomials in expanded form, that is, writing all the numbers as a product of their prime factors and all the variables multiplied together instead of in an exponential form like we'd see here. The greatest common factor can be factored out of a polynomial with all the remaining elements or factors left in parentheses. Let's see how this works. Let's take this 25 and let's break it down into its prime factors of 5 times 5. We get x cubed, so that would be x times x times x, and y to the fourth, which is y times y times y times y. Now we're going to add to that this 35, and we know 35 breaks down to 5 times 7. X to the fifth, x, 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 there's 5 of them, and then there's 2 y's, y squared. So what we want to do is look at each term individually and see if there is something in common. So right away, I see this term has a 5 and this term has a 5, and I like to circle it just to visually denote it. And now I've got another 5 here. Does this term have another 5? No, it doesn't, so I can't circle that 5. Let's look at our x's. This has 1, 2, 3 x's. This has 1, 2, 3, 4, 5 x's. So I have 3 x's in each one of these. So let's circle 3 x's. 1, 2, 3 x's. Okay? Let's look at the y's. Here I have 1, 2, 3, 4 y's, and here I only have 2 y's. So the most I can circle is 2, because that's the biggest number that both of them have. So the things I circled is my greatest common factor. That would be 5, x to the third power, because I have 3 x's multiplied together, and y squared, because I have 2 y's multiplied together. And then in parentheses, I said we're going to write whatever's left. So here that would be 5 y squared plus 7 x squared. Let's look at example number 2. 42, we could call that 7 times 6, and 6 we could break down to 2 times 3. 35, again, is just 5 times 7. So if we want to expand this out, we could write 42 as 7 times 2 times 3. We've got a squared, which is a times a. We've got b, plus 5 times 7, a cubed, which is a times a times a, and then b squared, which is b times b. So let's see here. Do they both have a 7? Yes. Let's circle the 7s. Do they both have a 2? This one has a 2. This one doesn't have a 2. How about 3s? This has a 3. This doesn't have a 3, so we can't circle the 3s. What about a's? So I've got one a here and one a here. I've got another a here and another a here. I don't have a third a on the left side, so I can't circle that a. I have a b in both terms, so I can circle the b. Okay? So our greatest common factor would be 7. A times a is a squared times b. And then in parentheses, in this one, all we have left is 2 times 3, which is 6. Plus, here we've got a 5 AB. We've got that factored out, our greatest common factor. In the third example, we've got 3 terms, 30x squared y to the fourth, 18x squared y cubed, and 12x cubed y to the fourth. Now, instead of breaking all these down into our prime factors, what we could do is just simply look at these numbers. We've got 30, 18, and 12. What do all of these have in common? Well, that would be a 6. That could be 6 times 5. That would be 6 times 3, and that would be 6 times 2. So if we wanted to write this out in expanded form, we could write that as 6 times 5 times x squared times y to the fourth plus 6 times 3 times x squared times y to the third minus 6 times 2, x cubed y to the fourth. Okay? Now this looks really long, but it's still the same process. So we've got a 6 in each one of these. So that would be part of my greatest common factor. And then what's the lowest number of x's that they all have? This one has 2. Second term has 2. The third term has 3, but we can only circle 2 of them because that's the lowest that the other ones have, or that's the most that the other ones have. Let's look at our y's. This one has 1, 2, 3, 4 y's. This one only has 3 y's, and this has 4 y's as well. So 3 is the most that they all have in common here. So I'm going to circle 3 y's on all of them. And let's look at what's left. Here we've got 6x squared and then y cubed as our greatest common factor. And what wasn't circled was the 5y. In this one, we've got a 3, and we've got a plus sign in between there. And we don't have anything else. Then we have a minus sign, and we've got 2xy. Try this last one on your own. See if you can't figure it out. This is a process that might be a little bit longer, but it always works. If you notice real quick on this last one, we'll do it real quick. We could call that 5 times 50. We could call this one 1 times 50. We could call this 2 times 50. And we could call this 1 times 50. So we'd see that 50 would be the greatest common factor in terms of our numbers. This one has an x, x to the fourth, x cubed, and a single x. So x would be our part of our greatest common factor because that's the most that they all have in common. And the y's, we have a y squared, y to the fourth, and y. So y would be the greatest common factor between all of them. So if we factor out the 50xy, I took care of the 50, I took care of the x, and I took care of one of the y's. So what's left is 5y. Here I took care of the 50. I took care of one of the x's, so that would be x cubed, and I took care of one of the y's, so that would be y to the first. So we'd have minus 1 x cubed, y to the first, and you don't really need to write that 1 there. Minus, I took out the 50 and x, so that would be x squared. I took out a y, so that would be y cubed. So I'd have minus 2 x squared y cubed, plus I took out the 50, I took out the x, and I took out the y. So since I factored this whole term out here, we're just left with a plus 1 to hold its place in the factoring. Thank you for watching. Hopefully this video was helpful to you. For more videos on factoring, stay tuned.